Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper trending on X, published on July 28, 2025, so just a few days ago. This paper introduces Kimi K2, a new model that is currently ranked as the #1 open source model on the LMSYS Arena leaderboard. The paper is titled Kimi K2, Open Agentic Intelligence, and as we'll see, its performance on complex tasks like software engineering is particularly noteworthy. It's a massive 1 trillion parameter mixture of experts model, and the authors detail a novel training process involving a new optimizer and a large-scale agentic data synthesis pipeline to achieve these results. And as you'd expect, there's a lot of buzz online. The conversation highlights this as a game changer for developers, a truly capable open source model that rivals closed systems like GPT-4 on complex tasks like coding and debugging. All right. So let's look at the numbers generating all this excitement. These charts compare Kimi K2 against other top models, both open source and proprietary ones like GPT-4 and Claude 4 Opus. The benchmarks are grouped into key areas like agentic coding, tool use, and math. And what you see is that Kimi K2, the blue bar, consistently comes out on top, or very close to it. For instance, on SWE Bench Verified, which tests the ability to solve real-world software problems, it scores 65.8, well ahead of most others. This strong performance across such difficult tasks really shows its advanced agentic capabilities. So a key question is, how did they achieve that kind of stable performance at such a massive scale? Well, these two charts illustrate a core innovation. The left chart shows what happens during a typical training run. The red line, representing attention logits, just explodes. Now, attention logits are raw scores that tell the model where to focus. And when they get too high, the training becomes unstable. The chart on the right shows their solution. Using a new tool called the MuonClip optimizer, they effectively cap these logits, keeping them under control. This stable training was crucial for training Kimi K2 without any failures. Okay, so beyond just stabilizing the training, the authors also improved the data. This table shows their rephrasing technique. Instead of repeating the same data over multiple epochs, which are full passes through the dataset, they generated new versions of the text, and the results are clear. Training on 10 unique, rephrased versions just once gives a much higher accuracy than repeating the original text 10 times. This table then details the model's architecture, comparing Kimi K2 with DeepSeek v3, and the design choices are really interesting. Kimi K2 has over 1 trillion total parameters, a massive 54% increase, but it's also more efficient. It has more experts, which are like specialized mini-networks, but activate slightly fewer parameters for any given task. It also cuts the number of attention heads in half. This strategy of increasing sparsity, having a larger pool of experts to choose from, is a key trade-off to boost performance, while controlling the immense computational cost. Building on that architectural choice, this chart really visualizes the why behind increasing the number of experts. This is their sparsity scaling law. On the horizontal axis, you have the amount of training compute, and on the vertical axis is the validation loss, which is basically a measure of the model's error, so lower is better. Each colored line represents a different sparsity level, and the trend is unmistakable. As you increase sparsity, moving from the orange line up to the purple and blue ones, the model achieves a lower error for the same amount of compute. So, with that powerful and efficient architecture in place, the next challenge is feeding it the right kind of data to develop those agentic skills. This diagram shows their really clever solution, a process they call an agentic data synthesis pipeline. On the left, they first build a huge tool repository, mixing real-world tools with over 20,000 new ones they synthesized with an LLM. Then they generate agents and tasks from that repository. The magic happens on the right, where they simulate an agent using these tools to complete a task. This generates a trajectory, which is the step-by-step record of the agent's actions. Finally, a separate judge agent uses a rubric, a set of scoring rules, to filter for only the best examples. This high-quality, filtered data is what ultimately teaches Kimi K2 how to act so effectively. So what we see here is a combination of stable training and that very clever agentic data pipeline. Together, these innovations create Kimi K2, a powerful open-source model that truly excels at software engineering and using tools. The authors have released it to help the whole community build more capable agents. That's it for this episode of the AI